this is 6. This is x. This is 8 minus x. What is this piece?
That's y.
Y, but what is it?
Radical x squared plus 36.
I was, okay. Right?
So it's on the other side. Okay. It's minus.
So is the radical x squared plus 36 times 100,000. Right? That distance is 100,000 apiece. Plus Harrison. Everybody's reading it. You don't need to read to us, bud. Times 75,000 is equal to my cost. Right? How do I minimize it?
Set it equals 0 and find the derivative.
We'll find the derivative and set it equal to 0. Okay. So is the derivative to this 1/2 x squared plus 36 to the negative 1/2 times 100,000 times 2x.
What's this? Oh. You did 16.
Minus 75,000
Yes.
equals 0. Is that right?
Yes.
Which is 100,000 x over the radical x squared plus 36 equals 75,000. Right? Two and 1/2 cancel each other out. So does 100,000 x equal 75,000 x squared plus 36? Radical x squared plus 36. Right? What are you going to do now?
Oh my gosh, I did this by...
Square both sides. So this is like zeros. X equals, what's 75,000 squared?
Wait. Does it not work if you divide by 75,000?
Wouldn't that be easier? It might be. Okay, yeah, it'll work. Let's do that. Get rid of some zeros. So is that, huh?
I got 1.332.
4/3? That's much better. Equals the square root of x squared plus 36, right? Now square both sides. 16/9 x squared equals x squared plus 36.
I got that. I got that. That's how I did that.
All right. So can I get the x's on one side?
I don't know.
16/9 minus x squared minus 1x squared. 7/9 x squared equals 36. So x squared equals 36 times 9/7.
197. Oh, you divided by.
What is x? Huh? Good.
I got that, but I did not know.
That's miles. Maybe you figured your own way.
Yeah, well, I think I did it wrong, but I got it right.
I thought I did it wrong, and I got the exact same thing as that.
6.8 miles. What did you find?
But then we have to.
What did you find? I found this distance. Right? What does it ask for? How far from A, which I found. Now, what will the cost be? The cost is, I put 6.8 here. Get that number times 100,000, right? What'd you get?
9 points, I think it would have been something.
907,000.
Wait, you have got what?
987, yeah.
980.
907,087.
Ah, that's 907 million.
Yeah.
Wait,
No, but you have the beautiful point.
Yeah, that.
Oh, where's the point?
It's 907,087.697. Okay, well, I got a different answer.
087.
0.697. What did you guys got?
That's exactly what I got.
You multiply 100,000 by y, 75,000 by 896, right?
Yes. That's the first one. Plus, now I need 8 minus x.
Then, okay, that's probably.
8 minus x is like 1.1 something
197.
Yeah.
times.
Use the whole number?
yeah, are we supposed to use the number? Because I rounded.
I didn't.
No, it's okay.
I didn't round, but I did not get that answer.
I'm not through.
Well, no, I know, but I keep saying I got 907,114.
That's what I read.
Okay, you'll be close enough. And then what is, how much does it cost on land? Times 1 point, huh?
Nah. I got 89,775.
89,775.
Yeah, but I didn't use the whole number, so.
That's okay. And then I add those together to get the total cost?
Wait, I should get the
All right, I'm going to set you up on 12, and then we're going to have today's lesson. All right? We talked about 14. Well, you got to talk faster than you talked on that one. All right? A rectangular 12. The rectangular page is containing 24 square inches of print. Right? Have you even read it?
Yes.
How many of you drew a picture?
I did. I drew a picture.
I drew, I think 3
Okay.
pictures.
Here's my paper. Correct? Here's my print. And I'm going to call this x times y. So is x, y equal to 24?
Yes.
No.
Yes.
I read it very
What,
right. Yeah, that's probably what I did wrong then.
what I did was I labeled like the outsides of the pages as X and Y, and then I did X.
You can get there, but that's the harder way to do it.
Yeah, that's what I did.
That's the harder way to do
I
it.
tried those basic and failed at each one.
So, I want to know how big the paper is. Isn't it one here and one here?
Yeah.
So isn't this side x plus 2?
Yes.
Since it's 1.5, is this side y plus 3?
Yes. Yes. Okay, I I see what's
But
happening.
is y equal to 24 over x?
Yes.
So is it true that 24 over x plus 3 times x plus 2 equals my paper?
That's a lot easier than I thought it
This
would
is what I did, and now I have this. So,
Well, it sort of won't cut it.
okay, see,
be.
I was so confused.
I didn't. Okay, so the main
You don't think
confusion,
it's funny?
I am happy.
It's good. It's following. I agree with it.
I don't understand it at all.
That means like AP sucks, so not do it next time.
Oh, that's way easier than I thought it'd be. I was thinking the gorilla had like a deeper meaning to it, and the sumo guy had a deeper meaning.
That's basically what it says, isn't it?
That's like,
I thought the sumo had something to do with.
Guys, can I set up 14?
Yes, please.
And then we're moving on. I'm done. I think I've done more of these than you have.
That is the answer.
yeah, and I just have a quick question on 13. Like, it doesn't require you to do any math, it just requires some explanation.
Is the volume equal to pi r squared h?
Yeah, how do we know that?
Because you learned it like 6 years ago.
Exactly.
So is 24 pi equal to pi r squared h? I want to find I'm solving for r. Okay? Because I can't have two letters. So I need to solve for either r or h.
So for
That's true. But then you have a square in it. So you want to solve for h?
yes.
Is h equal to 24 pi over pi r squared? Right?
Yeah.
They do. So is h equal to 24 over r squared? Right? Now, how do I find the dimensions of this? It's open at the top.
I don't even know.
Is the bottom pi r squared? Plus, what's the side? 2 pi r times what? Yes. 2 pi r h?
What?
Does this equal the area?
How do we do that?
How do we know this?
6 years ago, guys,
Yes.
you learned how to find surface area of a cylinder.
What is surface area? First question.
How much metal is in a metal can? Surface area.
Is it like a?
So do I have pi r squared plus 2 pi r times 24 over r squared?
Simplify that before we take over.
I would.
Okay, and then, okay, on 13, I'm confused. Are the rectangles on the sides the same size as the rectangle on the bottom?
No. It could be, but it doesn't have to be.
Is that what we're trying to find?
Find the dimensions that will minimize the cost. what's called linearization. Linearization, all it is it defines a tangent line. Okay? I'm going to give you a formula for it. The linearization is equal to f of a plus f prime of a times x minus a. That's the linearization formula. All right? So what we're going to do is first find the linearization at x equals a. Okay? We're going to find the linearization. This is the problem. F of x equals radical 1 plus x. And a equals 0. So now I'm just going to do the formula. All right? What's f of a? Isn't f of a just 1? 1 plus, what's f prime of a? Is
1/2.
f prime equal to 1/2 1 plus x to the negative 1/2, which is 1 over 2 radical 1 plus x, correct? So what is f prime of a? 1/2 times x minus 0.
How do we get 1/2?
And how do we get 1/2?
When I put a 0 right here,
Oh, that's 0. Okay.
0 in there. Because f prime of a. So we put a 0.
all right. Are we good?
What is this?
Do we need to like simplify that anymore? Or?
Yeah, I'm going to.
What's the difference between the a's and the x's?
The a you plug into x.
That's right. So is the linearization equal to 1 plus 1/2 x? That's my first thing that I did with the problem. Okay? Now, what I want to do is I want to compare L of a plus 0.1, and I want to compare it to f of a plus 0.1.
So they equal. We know that.
Well, I want to compare them.
Why 0.1?
They're going to be pretty close.
Are they just 0.1 just what we do?
Yes. So, what am I plugging in now?
1 plus 1/2 x.
What's A?
0.
So am I plugging in 0.1? So when I plug 0.1 in here, what do I get for L? Huh? I thought you said it. I just 1.05. Right? Now, what is f of a plus 0.1?
Well, okay. Do we plug in 0 or I don't know
What is a?
0.
1.0488.
1.0488.
Oh my gosh, that makes sense actually. Okay, that makes sense.
Oh, I plugged in 0.01.
So they don't equal.
Well, I'm comparing them. How close are they?
Very close.
They're within 2,000ths. They're within like 0.1 2,000ths, right?
Yeah.
So how close are they?
pretty darn close. Do I write that down?
They are, let me see how the book words it, just to tell you, okay?
Look pretty darn close.
Do they differ less than 2/1000ths? That's all you would need to say. Okay? Good with that? Everybody good with that? All right. Now we're doing differentials, which means, all it means is, I'm going to take the derivative of every letter in the equation. Okay? Here is my equation. Here is what I'm given. X equals 2, and dx is 0.05. I'm asked to find dy. All right? Are we good?
Still kind of on that last one.
Well, can I take the derivative of this? Everywhere there's a letter, when I take the derivative, I would put dx or x prime. I'm going to put dx. It's the same thing. What is the derivative of x?
1.5.
1 dx. What's the derivative of y? Equals, is this
Particle.
a product? Which is the first times the derivative of the second plus the second times the derivative of the first. Right? Now we just plug in what we know. I want to find dy. Do you know what I'm missing? Y.
I don't know.
I am missing y.
Oh.
Aren't I?
Yeah.
Can I use x in my first equation and find y?
Yeah.
Would you find y for me? Two plus y equals 2y. Y is 2. So I'm going to fill in everything I know. What is dx? Plus, what is dy? That's what I want to find.
dy is -1.5.
No, you're through? Equals 2 dy plus what?
That's 0.5.
2 times 0.05 is not 0.5.
Oh, dang, I did, okay, yeah.
So is negative 0.05 equal to dy? Okay? A little bit better than those word problems, right?
Whoa. How do we get